Hi students, today we are going to see a new topic, molybdate as anti-corrosive agent, that is molybdenum conversion coating, a green inhibitor for corrosion protection. You know, I am Dr. S. Rekha from RMD Engineering College, Chennai. So what is molybdate? First, let us understand what is molybdate. Molybdates are salts or esters of molybdic acid containing the molybdate ion, MoO4 2- ion. This ion reacts with the metal and forms the metal molybdate. They are considered environmentally friendly corrosion inhibitor, especially as a replacement for chromates. See, we have in a row phosphate coating, chromate coating, molybdate coating. In that, chromate coating is not environmental friendly. So to replace that, we have a environmental friendly molybdate coatings. Why to use molybdates, right? Non-toxic alternative to chromate, effective in neutral to slightly alkaline environment. Okay, if you are having a neutral environment, then you can use such a coating. If you are going to have a slightly alkaline, that is up to 8 pH, you can use this coating. Okay, for acidic environment, it will not work. For higher pH range, it will not work. Stable and compatible with various metal, forms protective passive layer on metallic surface. So we can use this molybdate coating. Molybdate conversion coating, it is a chemical surface treatment, we can say. It is a chemical surface treatment. So it gives a thin adherent protective coating on the surface of a underlying metal. So the metal reacts with the chemical and converts itself into a protective layer. So what is the layer made up of? It is made up of molybdenum oxide or complex molybdate compounds which protects the surface. So it can be done on steel, zinc, aluminium, magnesium, etc. Okay. So how it is done? It is done by immersion technique or by spraying the solution on the surface. Okay. Generally aqueous solution which is sprayed on the surface. Example, sodium molybdate or phosphomolybdate. This conversion layer acts as a corrosion resistant film and simultaneously provides an excellent base for paint. Mainly it is done to improve the adherent property of a painting surface. Okay. So excellent base paint, adhesives and subsequent coatings. Okay, over which you can give a subsequent coating. Let us see the parameter, that is what is there in the molybdenum bath. Okay, you prepare a molybdenum bath, either you give an immersion coating or you spray on the surface. So what is this bath comprises of? Bath composition, we have sodium molybdate 0.05%, zinc sulfate 0.02%, sodium tetraborate 0.02%, which plays the role of buffer. pH adjuster, NaOH is used as a pH adjuster. So this works with a temperature of room temperature to 60 degree Celsius. So we have a pH range of 7 to 9 basic. Okay. Immersion time 10 minutes or it gives 1 micron thickness or slightly greater than 1 micron thickness. Okay. If you plate it for 10 minutes, if you allow it to go for immersion for 10 minutes. So what is the application method? Already I told, it can be immersion, it can be spray, it can be brushing also. So coating property forms a corrosion resistant molybdate layer, enhance the paint by adhesion. So it can be used as a improvement of surface adhesion. What is the process? Okay, how this process is carried out. So I can explain you with this diagram. So let me take a pointer now so that it will be easy for you to understand. So let us consider this as the metallic surface. Let us consider this the iron surface. Okay, this round portion is there. No, we'll consider it as an active site. Okay, the surface is rough. You know, for any coating to be applied, surface should be rough so that you have a good adherence, right? So these are the active sites. When this is dipped, this substrate is dipped into the solution on the active site, the iron molybdate is formed. How? iron which is on the surface dissolve into the solution, and same thing gets deposited over the surfaces. See, now we have the nucleation process taking place. Once the nucleation has taken place, in the sideways metal also, the iron molybdate start growing up. So it forms one single primary coating. You can see in the third figure. Okay, one single primary coating. Once this has taken place, still if I have the substrate on the immersion state, what happens? The layer starts building up in the second layer. That is, base we have iron. Over that we have iron molybdate. Over that again we are going to have iron molybdate. So secondary grains are formed on the surface. So secondary grains gives the thickness to the coatings. Okay, after that you can wash it and dry it. That's the process. If you take the surface and if you watch it under a high resolution microscope, okay, SEM, you can see that we have micro cracks on the surfaces. So is it worth using it as it is? No. So what we have to do, we have to fill in the micro cracks. So to fill the micro cracks, we can use it the sealing process. Okay. So there are a number of processes of sealing process. Anyone which is suitable for you can do. One thing is you can give a heat treatment, or you can dip it in a bath, or you can give a paint coating on the surface. To fill the cracks, you can apply the paint on the surface. So what is the process? Let me summarize. These are given in the word. First step is the dissolution of the metal surface. Second step is the primary coating is started forming on the surface. Over that, secondary coating is formed, and now it is removed and it is washed and dried. After drying, if we see micro cracks are there, then we do the process of sealing, right? So sealant solution or heat treatment is given. To summarize the whole process of molybdenum coating, molybdate coating, so what we have first, we have to clean the surface, then rinse it. Okay, then give the surface activation, that is dip it in light acid dip. Okay, what is that light acid used? Phosphoric acid or fluoride containing solution. Okay, after that you give the molybdate coating. Once the molybdate coating is given, then undergo rinsing. After rinsing, see, this molybdate coating happens in a slightly basic condition, right? So if you feel that you need to neutralize it, you give a dip in a slightly acidic solution. So it is an optional process. Certain process we do it, certain process we don't do it. Okay. Then go for drying it. Once it is dried, okay, then if required, give the supplemental coating, that is to fill up the micro cracks. Okay, so you can apply the paint or you can give a high temperature. Surface can be heated to high temperature so that it gets sealed. So with that, the process gets end. Okay, the product is ready for the application. So what is the chemical reaction behind this molybdate inhibition? Okay, so in the bath, I told we have 0.02% of zinc and 0.05% of iron, and iron also dissolves from the metal surface. So what is the reaction? So molybdate ion is the key factor here. So metal is Zn2 plus. So this reacts with to form ZnMO4. It forms on the surface of the layer. Iron also reacts with molybdate ion to along with water to form iron molybdate H2O, which forms a protective layer. What is the mechanism? See, this molybdate ion gets adsorbed on the surface, which is the anodic site. Okay, then it forms the passive layer, forming the molybdate layer with the iron, with the zinc, all those things. Then reduces anodic dissolution and corrosion current as the process goes on. Initially, dissolution will be high. As the secondary layers start forming on, dissolution is almost stopped. Okay, so it reduces the corrosion process. So this way, this reaction takes place. This side we have the, you can see the molybdate conversion coating surface. Okay, what are the advantages of this molybdate coating? Provides effective barrier protection against corrosion on ferrous and non-ferrous metal. I've listed the metals in the initial part of the video. Okay, it acts as an anodic inhibitor. Molybdate is take the role of the anode. It stops the dissolution of the metal, reducing localized corrosion like pitting corrosion. So this is used to mainly to avoid the pitting corrosion. Okay, environmentally friendly process. Already I told it replaces the chromate. improves adhesion of the subsequent layer. See, if you want to apply a paint over a surface where paint should be 100% adhered to the surface, first give this molybdate coating. So it forms a micro cracks, means it is a rough surface. Over that, if you apply paint, it gives a very good adherent coating, and this paint lasts for very long time. Molybdenum coating also protects from corrosion. So double layer protection you get it. Okay, or apply a sealant, apply lacquer over the surface, anything you can do. There are many processes to be carried out, any method you can use. Okay, less environmental regulation compared to chromate because it is environmental friendly process. Applications. So there are various applications about it. So we have application in automotive industry, we have application in aerospace industry, electrical equipments, construction and infrastructures, also military and defense applications, as well as general industrial applications. What is this? Automotive industry. So protects the car body panel, brake system, okay, fastener from corrosion while improving paint adhesion. So main purpose is either corrosion resistance or good adhesion for the paint. Okay, so before painting we apply this surface. Okay, so this is also given as a primer coating for aerospace industry for the parts top coat. Okay, in electronic industry, safeguard connector, housings, chases, everywhere corrosion resistant it is used. Construction also, durability of galvanized steel bars. Okay, roofing sheets, frames, etc. So military, it is used as for weapons, ammunition casing, field equipment, etc. from harsh conditions, right? Everywhere the application is corrosion protection and giving the good adherence. Okay, so general application also same thing. So this is a final comparison chart of phosphate, chromate and molybdate. Easily explained. See, toxicity. Molybdate is having low toxicity while chromate is having high toxicity. Even phosphate is having a low toxicity. Next class we'll see the phosphate conversion coating. Okay. Cost wise, molybdate is little costlier, moderate, but the other two processes low value. Okay. Environmental risk. See, this is the one which is having the least. We told environmental friendly. Chromate is highly corrosive or highly non-environmental friendly. The next level is the phosphate and lowest is the moderate. Okay, film durability, it has the high durability. Okay, chromate also has a high durability, but it has an environmental problem. Phosphate, we can reduce the toxicity, but film durability is moderate. So best film durability is high. Okay, so molybdate coating is best of all the three. Thank you, students. Hope so you have understood this concept very well. We'll meet in another topic as phosphate conversion coating.